Here we are suiting up at the Kennedy Space Center for our launch on June 20th. Again, Kevin Kriegel, the pilot, waving to his family. Jean-Jacques Favier from France, very eager to get into space. Susan Helms, all pressure checked, ready to begin her third space flight. And the alien here is Dr. Rick Lenahan, our veterinarian. And Dr. Chuck Brady, also eager to get into space for his first time. And from Canada, Dr. Bob Thirsk.
The launch morning schedule is quite quick-paced. No sooner had we suited up when it was time to head out to the launch pad, and the van would take us out there. During this walkout, we were thrilled to see some of our friends and colleagues who had gotten up early that morning to wish us all well as we were heading off on our mission. And waiting for us at the launch pad was our beloved Columbia, and at this point it seemed like it was a living creature as it hissed and fumed and groaned, and it seemed as eager as we were to get ready for the launch. The crew was greeted at the launch pad on the gantry by the closeout crew, who helped us put on our harnesses and our parachutes and check out our equipment before we got inside Columbia. The strapping in procedure is quite a busy and highly choreographed affair, and it's also a bit of an emotional affair as well. And for a first-time flyer such as myself, I found that my thoughts went to friends and family, to the emergency procedures that I was going to have to perform in the event of an emergency, and about this wonderful adventure I was heading off on. It was really nice for me to strap in the middeck at the same time that Tom Hendricks, a three-time flyer, was strapping in the flight deck. If Tom thought this was a safe thing to do, then I thought it was as well. And these wonderful views you have of the strapping in procedure are courtesy of a mini portable camcorder.
Toronto, checks. Radar. Roll it. Houston, Columbia's in the roll program. Roger, roll, Columbia. Beautiful view. Above the clouds. Okay, so I went down. 2 Mach 1. A little bit higher, Max Q. DC. SRBs are going. Good riddance. 103, 103. They go around the horn. Temps are coming down. Horn has gone around the horn. Columbia, negative return. Negative return, Houston. Columbia, performance nominal. Nominal performance. Turn your SOTU tour off and you can raise your visors. At Mach 25. Engines hitting the clock. Welcome to space, ladies and gentlemen. Yeah! Hit it! Not bad.
Well, it was just absolutely fantastic to see be in space and see this great piece of American technology come off the external tank. It was really difficult for Rick and I to focus on getting pictures of this, because here we saw the Earth and land masses and the oceans floating beneath us. But the external tank just did a super job and performed greatly.
This is a mission that had dual objectives. It was a microgravity mission and a life science mission combined together, but the focus of the very first day, right after we got into space, was to capture the life science data for documenting the adaptation process. So without any further ado, as soon as we desuited, people were working on experiments, which is probably a first in the shuttle program, as quickly as we did. Here you see Bob on one of our life science facilities It's a dynamometer, and what it's meant to do is help measure both the static and dynamic performance of the musculoskeletal system. We had several PI investigative teams that were part of this major experiment, and here you see some of the activities taking place.
Yeah, that's me strapped into the TVD now, being electrically stimulated involuntarily by a device which measures muscle contraction. Here's Chuck on the arm lever, and we're measuring torque output and muscle strength and degradation over the 17 days of the flight on the torque velocity dynamometer. And Chuck here is going through the different protocols. You can see the IBM ThinkPad up there on his right hand, and he's following those, and that interfaces with software in the TVD. Jean-Jacques is holding a hand grip dynamometer, and he is performing various protocols that he is reading on the ThinkPad screen up there in front of him. And they are anywhere from following torque curves to producing various contractions anywhere from 10 to 100% on the hand grip. And all this will be compared to ground-based data when we get back, when we are back now actually, and look at changes in muscle physiology. That's me again, and I'm on ALFI, the astronaut lung function experiment. And I'm about to get on there and start blowing into this tube, and it's measuring gaseous exchange in the lungs, and we're comparing pulmonary physiology on orbit to ground-based studies. And right there I'm interfacing with the keyboard unit and reading the LEDs and following the flow parameters up there on the screen. And also we used ALFI with exercise. We did resting PFTs. Here's a picture of Jean-Jacques with as many watches on, and the magic mask, and he has just gotten off the ergometer, and he's going on to ALFI right now to determine if there are any changes pre and post-exercise. Here's Chuck with the Olympic torch, and Chuck is hooked up to ALFI and the ergometer right now simultaneously, performing the exercises, and it's measuring his pulmonary output. And here's the rest of the crew offering to cheer Chuck on and sharing the Olympic moment with the torch. Now, that torch was later taken down by the orbiter crew and walked around the orbiter after we landed.
We had another study. It was not relative to the lung function or the musculoskeletal studies that we have already talked about, but we also were looking at the vestibular system, the neurovestibular system. Specifically on this experiment, the goal here is to try to capture what happens to eye and head movements and posture movements when the inner ear becomes confused about what's up and what's down. Without the effect of gravity, your inner ear doesn't really understand which way it's heading relative to the earth. And so when you remove that effect, the question is, how does the inner ear then translate to the eyes and head, how to move? And so we had a number of experiments. You can see some of them in progress here, where we were doing very disciplined head and eye movements. And likewise, we did eye movements with and without knowledge of what was going on in the immediate environment. And by comparing this relative to what was captured pre and post-flight, we hope to better understand how that whole inner ear, eye, postural integrated system works together. And of course, an application for this is, among other things, the study of space motion sickness, because we know that that's got an influence on how people react in space to that effect.
The award for the oddest-looking LMS experiment goes to the torso rotation experiment. This investigation also measures how the vestibular apparatus, or our inner ear, adapts to the weightless environment. We also hope to come up with a cause for this space motion sickness problem, which afflicts about half of all astronauts during the first 2 or 3 days of spaceflight. Here in the middeck, Jean-Jacques and I have just donned the equipment, which includes accelerometer packages on the top of our head and also on our back, and we're performing a strange-looking dance, which is actually important to calibrate the equipment. Since it's the only experiment on our flight that comes from Canada, I thought it appropriate on one of the data collection days to wear my Team Canada hockey jersey. We hope also that the results of this experiment will help improve treatment programs for people that suffer from motion sickness in settings on the ground.
Well, this is the latest in sleepwear here. You're seeing 4 of us come out of our bunks in the morning. This is a study looking at the circadian rhythms and sleep patterns. And this is the first time that astronauts actually had their brain waves measured at night during 6 nights on 4 subjects. You see us coming out of there. We're really a fashion statement here, as you'll see in just a moment. But Tom's getting us all up, and we're going to line up here in just a second with all our sleep equipment on. We think we're going to get really great data from this. We're looking at long-duration space flight, and hopefully we'll be able to help people rest better and be more efficient, both in space and here on the ground.
Of course, it's also important to try and quantify the changes in performance. And on this flight, we flew a small laptop computer, which we would practice with a few times before flight, during flight, and then post-flight, and we could see the changes in our memory capabilities and in our hand-eye coordination.
This mission was a life science mission, but also a microgravity science mission. And we had several field of investigations, including fluid physics. Here we see the fluid physics experiment called the BDPU for bubble drop and particle unit. Each PI had a special container we had to load in this optical bench, and we had to make some critical optimization before getting the hand to the ground and to the PI. These experiments worked very well, except one day we had a little problem that Kevin and myself and Susan are trying to fix, a shortcut in the connector. But when we got that fixed, we were able to get very nice views of boiling in this particular experiment, or convection driven by capillary forces, like for this bubble in another experiment. And we tried to get the best quiet conditions for these critical phases. Another important experiment was a material science project, a furnace in which we elaborated different kind of specimens, alloyed, aluminum alloy, for instance, as well as semiconductors. So we try to get the best environment, thermal environment, to study the kind of structure we can expect to get in space. And as you can see here, sometimes it's easier to work upside down to get accurate positioning of the cartridge inside the furnace. And Susan looks very comfortable doing that.
You can see that the Space Lab is very busy with activities and a lot of experiments. We also were doing some experiments on the flight deck. This is the voice command system. It's a voice-activated system for the payload bay cameras, and Tom and myself were working on this experiment and just seeing how well it performed on orbit. We also got great views of outside the Earth. We had a full moon, and it was setting. As it sets and goes through the atmosphere, it actually turned blue. So we had a blue moon, and on orbit, we had a real blue moon, which is a second full moon in a month. We thought we'd be fairly clever, and we videoed this down to Mission Control Center, but they were on top of us, and they had the song to play when we were videoing this down.
One of our best passes was early in the morning. We had a nice pass above the Mediterranean Sea, Europe, and Spain here. We were able to see our hometowns. This one was Spain and Madrid, hometown of Pedro Duque, our alternate. Then we had some of these beautiful islands south of the coast of France that we saw sometimes, and it was not so cloudy. And we continued above Italy and Greece, and it was a very nice award in the morning to wake up early just to see that.
We also had some marvelous passes over the United States. You may recall that during the end of June, it was absolutely clear over most of North America. And this is one scene here of us saying goodbye to California, currently over Nevada, New Mexico. There's Lake Mead near Las Vegas, nearly in the center of the picture. And one of the current events that happened while we were on orbit were the wildfires in the Grand Canyon area. And you can actually see those in the bottom left of the picture at this time, coming into the field of view just before we head over into Mexico on this particular pass. So as you can see, it was quite impressive from space.
Just absolutely fantastic to travel from 39 degrees north to 39 degrees south. And this is a view of the Appalachians, the Great Smoky Mountains from Tennessee to North Carolina. Now we're getting ready to come home. I don't think anyone's wanted to come home, but this is a view inside as we're preparing for entry. And as a rookie, I can't begin to tell you just what a spectacular light show it was. I was really glad there were 3 veterans on the flight deck with me, because I felt like the whole front end of the orbiter was coming on fire. As you can see, looking out the back, there's just awesome light show that's going on. And in just a second, we'll see the lights reflecting off of Tom and Kevin in front and illuminating fully in a darkened cabin Susan's face here. Just an absolutely spectacular show as we reached entry.
You saw videos of the launch. We also had that small camera for videos out the front. We're over the panhandle of Florida. If you look in the middle of the picture, it's kind of cloudy, but you can actually see the coast of the Fort Walton Beach, Pensacola area as we come to land at the Kennedy Space Center. It was an overcast day. We had clouds at about 20,000 feet. We're at the heading alignment cone. Tom's in a right-hand turn, trying to line up on Kennedy Space Center, runway 33. We go through the clouds, and this is looking out my window. This is what I saw on the entry day. We can see the rivers of the Kennedy Space Center as we make the turn. Coming around the heading alignment cone, we're doing about 300 miles per hour, and we roll out about 6 miles from the runway at 12,000 feet, pointing 20 degrees, nose low. Fairly steep approach. Tom's lined up right on the numbers for our landing there on that morning several weeks ago. Of course, the entry flight control team had gotten us to this point with a great effort by some of the folks here in the room with us today. Here we are at 2,000 feet, beginning the gentle pullout from that steep dive to approach the runway, using the lights to the left of the runway to achieve a 1.5 degree approach. Kevin puts the wheels down about 10 seconds before touchdown, and the airspeed is bleeding from about 300 knots down to a target of 205 at touchdown, and we're intending to touch down about here on the black marks. You can see that's about where we touched down, so the numbers worked out well. The pre-planned numbers at 195. Kevin pushes 2 buttons, which deploys the drag chute. I lower the nose to the runway, and then we can use the nose wheel steering system on the orbiter, much like an airliner, to track the center line, which you see here. It also has brakes like an airliner, so we're slowing it with the brakes at about 60 knots. Kevin punches another button which releases the drag chute so it doesn't drape down over the engines after we stop, and we continue braking until we come to a complete stop. And that's the end of the flight portion of the mission, but some of the most crucial data still had to be collected as these 4 payload crew members readapted to gravity. So we very efficiently, with the help of the folks here in Mission Control, egressed the vehicle. They began their data takes, and I think you can see from this that we were very pleased with the 17-day flight.